Hi guys, this is Dan Bentley giving you some general feedback from that self-assessed quiz you did in 24.3. And I've just got this slide up here just a reminder that when you do these self-assessed quizzes or problem sets, that it's not just answering the questions. You need to grade yourself, okay, on the question, grade each problem. And you also, something very important is that you've made a general reflection at the end of your paper. Okay, so a lot of them I've looked at, people are starting doing a really good job at this, but still some people are neglecting to do that. So if you want to get graded on this assignment, you must do that. Okay, it's just a pretty straightforward problem set. So let's get going on some of the questions. So it's just 4 integration questions. Okay, this one is a binomial squared, and there's a radical term in there, but that's okay. It's often easier if we write that radical as an exponential term, and then we're going to expand it out. And why we do this is so we can now take the integral of each term individually, and it's all just a bunch of power rules here to take the integrals. So I bump up that exponent and divide by that new exponent, and then, I don't know if you saw here, but when you were looking at the answers, there was an error here. I think they had 2 as the denominator here instead of 5. So if you thought you had it wrong, you were right. It is an error. Okay, and then we're just cleaning this up, okay, and tidying it up and putting it back in radical form. And of course, don't forget that plus c. Okay, question 2. This question, this is what, we're going to break this up. We're going to use some trig identities or something to make this a little simpler, to get it into a form that we can integrate. Okay, so they kind of give us a hint in A part. So I factor out that 2, and then I see that I have actual difference of squares. Remember that from your factoring days? Difference of 2 squares. So, and then once you do that, you see we have a nice canceling out of a couple of terms there, and then we can see that the A and the B are both 2. And then B part says hence. I circled hence because this is a very important sort of command word. When you see hence, you know that you are using what you just found in the next part. Okay, so we can now, in B part, we can now change the original expression to the one that we just found, that we simplified. And then we can just integrate both terms, and they integrate pretty straightforward. 2x minus 2 sine x plus c. And moving on, okay, so this is another good question, again, where you're going to break it up into an easier form so that you can then integrate it. And this is called partial fractions, and I'm sure you went through some examples on this. So what we're going to try and do is we're going to try and express our, just change our expression to be a different form. So what I've actually done here is I've gone, what they've asked me to do is ax minus bx over 2, and I've just trying to rewrite that, and I've got a common denominator there. And now as I distribute it out, I'm going to look at my x term. So both the a and the b have an x, so it's a minus bx and then 2a. So that's what I've done, and there's my denominator. Now I know that that's going to equal this because it told me that in the question. So that means that my x term here, or my a minus b, my x coefficient, is going to equal 1. And this is my other term. This is going to equal 4. Okay. And so then now just a small little system of equations. So a minus b equals 1, 2a equals 4, and then we can quickly solve an a to be equal to 2 and b to equal 1. And then, so now we are going to do the integration of this using the more simpler form, our partial fractions. And as we do this, we pull out that 2, and I'm just kind of showing you that we integrate each term by itself. And then hopefully you realize that when you integrate this, you get a natural log of x, don't forget your absolute value, and natural log of x minus 2, minus natural log, plus c. And moving on to the last question. Okay, so this one, I don't know, this was a trickier one. The first thing I did was kind of pull out that 3, but then I'm looking at this, and I haven't really learned too many techniques yet, but if I want to express this as a difference of squares, so, sorry, not a difference of squares, if I want to complete the square, if you remember from how we complete the square there, I added another term, in this case it was 1, and I subtracted that 1 as well. And why I did that is because now that gives me a denominator that you might recognize. Okay, and we have a denominator. If we have this form, something's on the denominator, x squared plus a squared, we know that that's going to be 1 over a arctan of x over a. So I'm kind of treating that x plus 1 as my x term and the plus 4 as my a term. Okay, so that would be a squared, so that would be 2. So there's my arctan, and I'm really just following the map of that formula. So that was a little tricky. You really had to kind of, it didn't jump out right away, but if you started playing around with that denominator, then you probably would have seen it. So, okay, sorry, talking a little longer than I expected here, but hope that went well. I think it was pretty straightforward. The ones I've looked at so far are pretty good, so well done. Looks like you guys are getting the hang of this. Okay, all the best.